Okay, so we're back with 3.8 and we're still like rewriting polynomials in factored form. When I say factored form, your brain should say parentheses, 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 okay? So whenever I tell you, hey, write this in factored form, you're going from something like this is called standard form, to something like this, right? So you do have to be familiar with what the answer should look like, right? But if I ask you, like, hey, what's your favorite color? And you say 7, that's not the answer. So you're giving me an answer to a question, but not the question that I asked. So factored form looks like this because these are factors. Factor, 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 right? So the very first thing that you do, it says, here's your function, here's your x plus 3. Do you know how to find, find the rest of the factors? So the very first thing that I do is like, yeah, I know how to find it. And this is all based on, remember when you divide, when I say, hey, is 7 a factor of 147, you guys divided. So the same thing goes here. If it works in number land, then it'll work in polynomial land, right? So then I divide. So the long division, not going to really go over it. So then you get an answer, x squared minus 4. And then you notice that your remainder is 0. And this should not be a surprise, like, oh, it's a 0. No, because they already told us it's a factor, you should have predicted that it's a 0. In fact, if they told you it's a factor and you don't get a 0, either you did something wrong or they lied to you. Okay, so then you have x squared minus 4, and then you factored x squared minus 4. I don't know. Oh, yeah. And so here's x squared minus 4. This is too big. Like I'm scrolling everywhere. And this is that difference of squares. And you can factor this without knowing that it's a difference of squares, but it's a little bit quicker. Where's the number in the middle? Exactly, because it's the difference of squares. So someone asked in the chat, hey, but where's the b term, your middle term? And this one doesn't have one because it's a difference of squares. And so if you multiply this all out, positive 2x and negative 2x, subtract, and it leaves a 0, which is why it's x squared minus 4. This is like one of those shortcuts, right? And if you don't remember that it's a shortcut, you would still be able to find the answer as long as you factor correctly. So the way I check my answer is I can plug it in. I can graph them. They should line up. I could check each of my roots. Now that I know that this is factored form, then I could take each of my roots and plug it in, and they should all equal to 0 when I plug it in, because that's exactly what, it's equal to. So we're going to continue on. I'm going to skip a couple of problems you guys can try on your own. You should get the same expected results that you did before checking your answers, of course. So I'm going to start with this number 7 because it says x to the 4th. And some of you already are recognizing this thing. And you're like, wait a second, where's all the people in between, right? And so I'll bring you back over here. It's probably because it's a pattern, right? It's a pattern. And so the difference of squares pattern goes like this. Hey, are you something squared? And you're like, yeah, that's x squared. And I say, hey, are you something squared? And you're like, yeah, that's 2 squared. And is it a difference? Meaning, is there a subtraction sign in between? And you're like, yes. So that means that entails that, that it's x plus 2, x minus 2. A plus b, a minus b equals 2, a squared minus b squared. Okay. So if you recognize that, awesome, right? If you recognize that this is a difference of squares, awesome. I'm going to pretend that you didn't, okay? Just so that I can show you that even if you mess up, it'll still work. So I'm going to bring this over here, and you'll notice that I'll leave some space so that I can have some room in there, right? So I'm going to divide x minus 2. I'm going to divide x to the 4th, leaving a lot of space for all my, my cube, my squared, my x. I'm leaving a lot of space there, minus 16, right? I'm going to pretend that I don't know that this is a difference of squares. If you recognize this is a difference of squares, awesome. If you didn't, don't worry, it still works, right? That's the good thing about math. As long as you have the foundations of it, you can apply it to everything over and over again, even your special cases, and it should still work, right? So here I go. X times what gives me x to the fourth. If you want to participate, great. I'm just going to move on. So that's x cubed. X cubed times x is x to the fourth, and then minus 2x cubed. I already can tell I'm writing too big. I should have left more space, y'all. That's okay. So then I'm going to subtract, which really just means I'm going to add the opposites. So the biggest mistake that I see people making so far in your videos and on your homework is that when you subtract right here, you forget to change this guy's sign. So be diligent in that, right? And can you all imagine that there's a 0x cubed above here? Can you guys all imagine that? Okay, good. So this cancels, which means I did this right. Woohoo! And 0x cubes plus 2x cubed is just 2x cubed. And then I'm going to leave space and then put my minus 16 down here because I still need him. I don't want to forget about him. So then I just repeat. X times what gives me 2x cubed, and that is plus 2x squared, I think. Yeah, that looks right. So then I'm going to multiply 2x squared times x is 2x cubed. And 2x squared is minus 4x squared. See, I didn't leave enough space. I'll just continue scooting people over. And then I'm going to subtract, right? But subtraction just means adding everybody's opposite, right? So there you go. All right. So then I'm going to subtract. So I get 0x cubed, which is good because that means I did it right. And then that's just 4x squared. And then leave some space, minus 16, right? So then I repeat. So then this is plus 4. Am I going too slow? You guys okay over there? All right, I'll speed it up a little bit. And then 4 times x, that's 4x squared, and that's minus 8x. And I'm going to subtract. Oops, I forgot to change colors. Sorry about that. And then I change everybody's to their opposite. These cancel. Woohoo! That means I did it right. Did I do something wrong? I did something wrong. Thank you. Thank you. Thank you. Thank you. Thank you. Sorry. This is what happens. Thank you. Thank you. Say you always have my back. I appreciate you so much. So yes, I forgot an X right there, not on purpose. I would love to say, yes, I did it on accident because look at me. I can't find my papers. So then 4x times, yeah, I still got it right. So in my brain, there was an X. You guys just couldn't see it. No, just kidding. I messed up. All right, so then I add, and this is 0, so that means I did it right, even though I did it wrong. That's funny. Okay, so then let's see. So then I get 8x minus 16, and then I say, what times that? Oh, well, that must be 8, so that's plus 8. And then I go, so that's 8x minus 16, and I'm going to subtract, and then I'm going to change colors and then add everybody's opposite. Look, it's a 0. Anybody surprised that it's a 0? Everyone's like, oh, I'm shocked. No, you're not shocked. Now, the reason why you're not shocked is because they already told you that x minus 2 is a factor. So now I have to factor this thing right here. This thing right here. Okay. So the next thing that I'm going to do is I'm going to be like, oh man, I don't know how to factor that thing, Miss Johnson. Good. So far, I already know one of my factors is going to be x minus 2. I now need to find, oh, by the way, how many more factors should I be finding? How many more factors should I be finding? Yeah, I should be finding 3 more factors. 1, 2, 3. And actually that answer depends on what my domain is, right? That answer depends on what my domain is. I've done enough of these to know that my domain is a little bit different here. So then what are you going to do, Miss Johnson? What are you going to do with this thing? How are you going to factor this? You haven't taught us how to factor cubics. You're right. I haven't. So what I'm going to do, if you don't know how to factor 147, what do? You just start trying, you start dividing numbers, right? You're like, let's say I didn't give you the 7, you'd be like, okay, well, let me try 1. And you're like, it doesn't work. Well, it's odd, right? Well, I wouldn't start with 1, sorry. I would start with 2. Oh, this is odd. So 2 doesn't go in there evenly. And then you continue all the way through, right? Wait, Ms. Johnson, you want us to continue all the way through? Kind of, but not really. So follow me over here. I'm going to go with this x cubed plus 2x squared plus 4x plus 8. Now I'm going to divide it. Now before, I got this x minus 2 because that's what they told me to use. But let's say, like right now, they didn't give us any numbers besides that. What would you do now, Miss Johnson? Anybody have any numbers? Can you throw a number in the chat that you think I should put as a factor, x plus or minus whatever number? Which one would you use? Can you throw some numbers in the chat? So I should use x plus, is that x plus 2 or x minus 2? What are you talking about? Sorry. You want me to use x plus 2. Is there any reason why you want me to use x plus 2? Give me a second. I'll help you in just a second. So I can change the sign because of the second term. Oh, interesting. So the biggest thing that I do, the reason why I think 2 is actually a really good number, plus 2 is a really good number to use, is number one, because I know that this is, like I said, a difference of squares. And if x minus 2 is a term, then probably x plus 2 is a term. But more so how I told you guys to really quickly check, right? When I told you to really quickly check, I said, multiply your first times your first times your first. That's x cubed. And then I also told you multiply your last times your last times your last, and that's your, that number is important. So like, for example, here, 3 times 2 is 6 times negative 2 is negative 12. Woohoo! Okay, so if you are looking at this problem that we're doing right here, and we're trying to factor x cubed plus 2x squared plus 4x plus 8, right? You want me to factor all this, right? If someone said the number 3, do you see how I would be like, okay, so where did you get the 3 from? Do you see why 3 would be a bad choice? Do you see why 2 would be a really good choice? Can someone put that into words? Why would I say 3 is a good choice and no, sorry, 3 is a bad choice and 2 is a good choice? Can someone put that into words? Like, why would I use x plus 2 as a factor and not x plus 3? Can someone put that into words? Yeah, someone said 2 can go into 2, 4, and 8. And I'm going to be honest with you, I really don't care about 2 and 4. Who's the only person I really care about? Yeah, I only care about 8. Ms. Johnson, why don't you care about 2 and 4? Aren't they important too? They are, but not as important as 8. Notice when I told you guys to do that quick check of multiplying first times first times first and last times last times last, who didn't I care about? And in fact, if you thought about that, that would really mess you up for this too, because look, 2 is not a factor of 3. But I really like your thinking here. So I'm so glad that you guys take risks. This is why you've learned so much, because you've taken risks when and you're looking for these patterns. Okay. So then I'm going to have you guys divide this out really quick. I'm going to pause the video. You guys are going to divide this out really quick and tell me what you get. So go ahead and do that. I'm going to pause the video. All right, so you divided. So I'm going to divide really quick. Hopefully I'm not making 0 mistakes. So I get x squared. This is x cubed. Oops, that doesn't look like a cube. Let's try that again. Cubed. And then we get x squared, and then we get 2x squared, and then we get subtract Miss Johnson. And then we add the opposites. So those all go away. Oh, Miss Johnson, look. All of them went away. What do? Bring down the next couple people. Okay, so then I get 4x plus 8. And then I say, okay, well, x times what gives me 4x? And I get plus 4. And you're like, oh, yeah, that's right, Miss Johnson. You said something funny was going to happen. Look what happened. All these people went away. Exactly. So then I multiply. So that would be 4x and 8. And then I'm going to subtract. So that means I need to change my signs. So this is 0. Are you surprised that this is a 0 as a remainder? Uh-oh, it's not catching up. Are you surprised that this is a 0 as a remainder? Everyone's like, no, Ms. Johnson, because you already proved that. No, actually, we should be a little not surprised. We are excited that it's a 0. I guess I should say. I'm relieved that it's a 0, rather. How about that? Okay, so then now all I have to do is factor this thing, Ms. Johnson. Yeah. Ms. Johnson, this is also missing a middle term, but you said it was a difference of squares, and this is an addition sign. So does it still work? Kind of, but not the way like you think. So the first thing I'm going to do is I'm going to add in my little factor over here. So I keep track of all my factors, x minus 2, x plus 2. And then I'm going to look at this guy and be like, what do I do with him? So the very first thing that I want to do is I want to solve him. I go x squared plus 4 equals to 0. Because remember that if I know what, and this is the thing that we focused a lot on yesterday, was if I know my roots, then I know my factors. And if I know my factors, then I know my roots. So let's take a quick pause really quick. Since these are my factors, what so far are my roots? Since these are the factors so far, what are my roots? Exactly, right? I got 2 and I got -2. Very good. Very, very good. Okay. Sorry, I'm trying to look for my attendance roster, which I need to take attendance and give you guys a bunch of like wonderful participation points because you guys are rocking. Okay, hold on. Let me just catch up to you. Okay. All right. Very good. Sorry, we have a mess on my desk. Okay. So because my roots are 2 and -2 from my factors, now I can go find my other roots, and I'm going to go this way now because I can't figure out what my rest of my factors are. Can I figure out my roots, Miss Johnson, and then write my factors from that? Yes, that's the way I'm going to go right now, right? So if I get a little stuck, I tend to solve for x, and then I find my roots and then say, oh, that's what my factors are. Okay. So how would you solve this equation? What would you do? What would you do here? What would you do? Yes, I would stat map this guy. Exactly. I would subtract 4. Very good. Thank you. So I'm going to subtract 4. So I get x squared equals to -4. Had you been in integrated 2, y'all would be like, you can't do this. It's no solution, right? You guys would all say something along those lines. But because you know and have access to complex solutions, then we know that we can take the square root of both things. As soon as I say, okay, well, sorry, I should have said this. How do you get rid of the squared? How do I get rid of my squared, guys? Yeah, I take the square root. What am I going to say right now? Who knows what I'm about to say? Who knows what I'm about to say right now? Yes, that's exactly what I would have said. I would have said, don't forget the square root. If you take the square root, then don't forget the plus or minus. I am a lot off here. Okay, so here's x is equal to plus or minus the square root of -4. Anybody remember how to simplify the square root of -4? Anybody remember how to simplify square root of -4? Yeah, there's an I. So let me take out my I. So ignore my I. So I'm covering my negative sign on purpose. So what's the square root of 4? 2. So therefore, what's the square root of -4? Yeah, plus or minus 2i. Very good. So x equals to plus or minus 2i. Please do not be deceived and think that this is some hybrid number. It's not. It's just 2i and -2i. So of course, that means I'm going to come back over here and write, I'm not going to write it as plus or minus 2i. I'm going to write 2i and -2i. Okay. So since I know my roots, does that mean I can write my factors? Since I know my roots, now do I know my factors? Yeah, can you write out my factors for me? Can you write out my factors for me? Awesome. Thank you so much for those of you who are participating and plugged in right now. That's super helpful. I really, really appreciate it. Very, very strong work there. Thank you so, so much. I appreciate it. All right. Yeah. So then our factors are going to be x minus 2, x plus 2. And from these guys, I'm going to get x minus 2i and x plus 2i. Okay. So let me just say, if you weren't in, if I said, but your factors can't have, I mean, they're saying like, factor it, you know, in terms of real numbers, I would have just left this as x squared plus 4. But because you know your factors and you know complex numbers, then we can write x minus 2i, x plus 2i. Does that make sense? Awesome work. So any questions on this? I'm going to show you my shortcut. If you recognize that this is a difference of squares, you would have seen x to the 4th minus 16 as x squared squared minus 4 squared, right? So you would have seen this as a difference of squares. And then because you knew that was a difference of squares, you can separate them out into plus and minus, like a plus b, a minus b. So then I would have said x squared plus 4 and x squared minus 4. Do you see my x squared plus 4? Do you see how he popped out there? And then you would have said, hey, Miss Johnson, I see a squared minus squared again. And I've been like, okay, we'll do it again. So then you would have done x plus 2, x minus 2. And with this x squared plus 4. Now, for those of you who are really proficient, you can kind of think about this and be like, Miss Johnson, this is squared and this is squared. Couldn't you have just written x plus 2i, x minus 2i? Yes. If you recognize that, if you don't see that, that's not a problem because I just showed you a different way to do that. So how would you check your answer? I'd plug it into Desmos. You know what? I don't know if Desmos takes complex numbers. So let's see. Let's discover it together. Pretty sure they would, but not very sure. So x plus 2, x minus 2, x plus, let's see, 2i. Oh no, it doesn't. It doesn't take it. It thinks it's a variable, not a complex solution. Yeah. So you would have to plug in this real guy right here for this. So I'll show you. Looks like this. And then I would plug in this guy, x to the 4th minus 16, and it should be the same exact guy. And you guys are like, boom, Miss Johnson. It is the same. I'm so excited. Look, you guys all see they're the same. Miss Johnson, that kind of looks like a parabola. It should, right? Because like squared, right? To the 4th is like squared. But he's a little bit flatter here. That's how I can tell that he's not a parabola. If you look at him, right? Like zoom in. He doesn't behave like a parabola does at his quote unquote vertex, right? So that's an observation that you should make for sure. All right. This one I'm doing for sure because it has a factor of x minus 2i. I want to tell you, if you treat him the same as you have been, like dividing and stuff, it'll work out exactly the way you want it to. I'm just going to move that off to the side just so I have more room. So I'm going to do this really quickly. And I just want you to think, I'm treating him the same. Okay. The other thing is that I want to tell you is eyes. Have you ever seen an eye without his partner, his pair? Have you ever seen an eye without his partner or pair? Actually, can I ask a different question? How do eyes come about? I'll say it like this. Where did we get this I from? Yep, right here. There's two of them. I's come in pairs. Your I's will always travel in pairs. What do you mean by pairs, Ms. Johnson? Plus or minus, right? Oh, so the fact that they gave me this factor, how many factors did they actually give me? Yeah, they actually gave me two. So let's write them down. Can you write your two factors that they gave you down right here, please? Can you write the two factors that they gave you down and then put it in the chat? You guys are doing fantastic. For those of you who are, I get it, some of you are pencil and paper and you're writing it all out. For those of you who are not and you're not engaged right now, I'm worried about you. That's all I can say. I'm worried. I'm concerned. Right? Yes. So, also write your roots out. Since you already know this guy, someone's like, oh, Ms. Johnson, can I also write my roots out? Absolutely. So you should already give me two roots and two factors. Two roots, two factors. Very good. So some of you already wrote it. Some of you said, Ms. Johnson, because they gave me x minus 2i, we include his buddy, also known as his conjugate. Technically, this guy is called his complex conjugate. Do you remember we talked about conjugate yesterday where the term stays the same, but the operation between them flips? So it's now minus and now it's plus, right? Right. So then there it goes. Okay, so those are my two factors, x minus 2i, x plus 2i. And then therefore my two roots I already know are 2i and negative 2i, right? So Ms. Johnson, since I already know that is true, instead of dividing by x minus 2i, can I divide by, what would you, I mean, here's your choice. Here, I'm gonna show you what I mean. Would you rather, this is a would you rather game, right? Would you rather divide x cubed minus x squared, plus 4x minus 4, would you rather divide it by x minus 2i, or would you rather divide it by something else? Why don't people want to divide? Why would you say that this is very intimidating for someone? Why do you think this would be intimidating? Yeah, that I is another thing that I have to keep track of, and I don't want to have to keep track of it. So instead of dividing by x minus 2i, is there something else a little bit easier that I could divide by, Ms. Johnson? The answer is yes. What else should or could I divide by, knowing all this information that I have in front of you here? What else could I divide by? Not x minus 2. Oh, I see why you're saying x minus 2 because of this, right? Yeah. Can you multiply your last times your last? If you multiplied your last times your last, what is that? What's negative 2i times 2i? What's negative 2i times 2i? So in case you don't know that, let's do that together. Negative 2i times 2i. Let's go slowly here. What's a negative times a positive? Negative. Good. What's 2 times 2? Good. What's I times I? I squared, right? Good. What's I squared? What is I squared? So if I equals to the square root of -1, I squared equals to square root of -1 times the square root of -1, which is what? Yeah, it's -1. So this is -4 times -1, which is just 4. Okay, so Ms. Johnson, you wanted me to multiply those two. Why? Oh, because I'm going to do that check. Right. Okay, so do the check with me. -2i times positive 2i is -4i squared, which we figured out is 4. Oh man, that's a -4. What do you think is going to be our last factor? What do you think could be our last factor? Based on this, yeah, it's going to be x minus 1, right? Because remember, if you multiply your last times your last times your last, you should get the last term. So negative 2i times positive 2i, you just told me it was 4. 4 times negative 1 is negative 4, yes? That's one way to do it. I wasn't referring to that. When I said, what else could you divide by? I was referring to if I multiply these two together, I would get, and we just did that, right? We just multiplied these two together, and remember we got x squared plus 4. That's actually what I was referring to in terms of dividing. I was saying, hey, it's easier to divide by him times his conjugate than actually just him. Multiplying by him is fine. You will be able to do it. You just have to keep track of your i's, which is really annoying. Okay. It's hard enough to keep track of your x's and your numbers and all this other stuff. So I would divide by x squared. I'm going to show you that really quick. This is actually the last factor, which is pretty slick. So this is a slick thing, but it's not a guarantee. So if you do this and you're like, oh, it's just negative 1, it could and could not be that. So just pay attention, make sure you check. So I'm going to divide by this just the same way. Ms. Johnson, this feels weird because there's no middle term here. I just make sure everybody lines up. So x squared times x is x cubed. So then I go x cubed, and then x times that is 4x squared, right? 4x squared, yeah. No, 4x. Wait, what am I doing? X times 4 is 4x, right? Okay, and then I'm going to go change my signs. And you're like, Ms. Johnson, it's weird because there's nobody here. It's okay. Just pretend there's a 0. Just pretend there's a 0. Okay. And then this goes away, which means I did it right. Yay. Hey, make sure that I actually did it right because, you know. So I get negative x squared, 4x minus 4x is 0. Oh, that's convenient. Minus 4. And then I say, hey, x squared times what gives me negative x squared? And then boom, it's minus 1. And you guys are like, hey, Ms. Johnson, you were right. I know. Isn't it great when I'm right? Just kidding. All right. And then you're going to subtract, and then you're going to add the opposites. I didn't change colors. So then we get that, which is 0. So this tells me that number 1, this is a factor. Number 2, here's my last root. And then, my last factor. And so I would just have to add in my last root. If x minus 1 is my factor, then 1 is my root, right? Everybody okay with that? Yeah. Okay, so there goes that. So they ask questions like, is it possible for a polynomial with real coefficients to have only one non-real complex root? We just talked about this. Is it possible for a polynomial with real coefficients? 1 is real, negative 1 is real, 4 is real, negative 4 is real, to have only one non-real complex root? You only have 2i as a root. Everyone says what? Say it. What did we say? These guys travel in what? Yeah, they travel in pairs. So can you have one non-real complex root? Can you have one non-real complex root? No. Why not, Miss Johnson? Because how are you going to get I from, okay, you get I. Where do you get I from? Everyone says what? The square root, right? Oh, yeah, yes, from the negative under the square root. Very good, sorry. So I get i's out of taking the square root of a negative number, right? But remember, when Miss Johnson says every single time you take the square root, what do you need to do? Everyone says exactly, plus or minus. So if you have a plus or minus, now do you understand why they have to travel in pairs? Does that make sense? They travel in pairs. It's like shoes, right? I can't get a left shoe. I can't just go to the store and be like, you know, I have this pair of shoes at home, and for some reason the left shoe got lost. Can I just buy a left shoe? And everyone's like, no, you gotta buy the pair. So eyes, like shoes, travel in pairs, right? If you have one, you automatically know you have its pair, okay? Called its conjugate, Okay, so that's a good explanation. Based on the fundamental theorem of algebra, remember, if I look at my highest root, 3, I should have 3 roots, 1, 2, 3. And the polynomials you have seen, make a table that shows all of the number of roots possible combinations of real and non-complex linear for quadratic, cubic, and quartic. So what are they talking about, Miss Johnson? So they're saying like this. So if you take a cubic, if I take a cubic, tell me all the different kinds of ways that I could have roots. Well, here, maybe I should make this table real quick just so that we see. Like this. I think it's going to be like this. So here, this is going to be polynomial degree. This is going to be roots, type of roots. Oops, type of roots. Okay, so let's say, I just want it to be bigger. All right, so the type of roots, right? So let's say we have a cubic. How many roots are you going to have? Everyone's like 3. Good. So name off the different combinations that I could have of those roots. Now here we have 2 complex and 1 real. So here we can write 2 complex, 1 real. 1 real. Right? What's another combination that I could have of those 3 roots? What's another combination that I could have besides 2 complex and 1 real? Good. I could have 3 real. What else can I have? Can I have 3 complex? Good. Why can't I have 3 complex? Very good. Why can't I have 3 complex? Yeah, because they come in pairs. Very good. Can I have, so this is all the combinations that I could have. I could have 3 real, or I could have 2 complex and 1 real. There's no other combinations I have. So what they're asking for is, can you do it with a quartic? So you'd have 4, and then so you'd start off with, okay, I can have 4 real, right? What's another combination that I can have? Yeah, 2 real, 2 complex. Someone says 4 complex. Did I spell? I keep spelling complex wrong. My finger wants to write complex. And then that's really it. You have 4 real, right? And you have 2 complex, and you have 4 complex. Okay. There's other ones that you can talk about, like you could have 1 real that hits it 4 times. You remember how like we looked at that x squared and it was 1 root, but it was multiplicity 2? I'm not talking about those. You can list all those out if you'd like, but I'm really talking about the combinations of them. Okay. So, and then they wanted you to do a quadratic, so squared, and they want you to do 1. So they just want you to fill this out. Okay. Very good.